Hi everyone, in 3.4 we're going to make our last little baby step before we get to our big application of this section, which is a physics application, work problems. So we'll need to add on one more piece to do work problems, but this will get us really close. So I want to look at density problems, and for anyone who's taken a lot of science, let me just say that science talks a lot about mass density. And we will see that, but that's not the only kinds of density we're going to look at. So just remember, think about density as how spread out something is. How dense is it, right? So we want to know if there's a lot of it packed into a small distance or area or volume, or if it's spread really thin and there's not a lot of it. It's not packed very tight. So we're going to start with the easy problem and then work our way up to the calculus version just to make sure we're getting exactly what I mean when I say we want to work on density problems. So if density tells us how tightly packed something is, our goal in these problems is going to be if we're told how tightly packed it is per unit length or unit area or volume, whatever it is, I want to be able to calculate the total amount of whatever that thing we have the density function for is. So as an example, let's say we have a line of people, uniform density. We know there are 2.5 people per yard. You can see, so the densities are kind of written as rates almost, right? We know how many people there are per yard. We know that the line is 8 yards long. We want to know how many people are in the line. So we can use units to help guide us here. If we have people per yard and we just want number of people, we better multiply by yards. So again, this is supposed to be a simple problem. We'll make the calculus version in a second. 8, 8, 16, and 4 is 20. So this is 20 people. Okay. So that is easy because it's uniform density. If everything's evenly spread out, it makes these problems really easy. So let's look at number 2, and then we'll do a different video to work on some of the calculus versions. Okay, so in number 2, we have a colony of bacteria, again with uniform density. So we know we have 40 bacteria per square centimeter. So we're knowing the density of bacteria per unit area. We want to know if these are spread out on a circle, that's a really ugly circle, with radius 3 centimeters, how many bacteria would there be? So if I have 40 bacteria per square centimeter, and I just want total number of bacteria, I better be multiplying by an area in square centimeters. Since this thing is a circle, the 3 is not enough, that's just centimeters. I need 3 times 3 centimeters squared, which is the same as saying 9 pi centimeters squared. And notice the centimeter squared cancel out, and I get 9 times 4, 360 pi bacteria. Okay, so easy when everything is uniformly spread out. In the next video, we'll get into not so uniformly spread out.